Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT from Weather Risk, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about This Week in Weather for this March 14, and just lots of interesting spring weather to talk about. The winter's pretty much over and done with, and we'll get to all of that details here as we go on. There's a picture of the website. You can go there. Lots of different products of the offer under the shop tab in the top up right corner there. You can see that. Local forecasts, grain weather for commodity traders, 30-day forecasts, and that sort of stuff. Anyway, here's the two Twitter pages. This is the one here, the snowstorm page, which in April, I guess I'm going to change over to the hurricane page, and then also the threads page on the right-hand side for those who don't like to use Twitter. And then this is the grain page. All right. And of course, here's the Facebook page, as always. Okay, first we'll take a look at this, the MJO for the next couple of weeks. What's going on here? You can see that right now we are generally right about here in phase 5. Then it's going to go to phase 6, which is a fairly mild phase, phase 7. But then look what happens once again. It will not go into phase 8. There's phase 8, and look what happens. They all turn it into neutral circle. See that? Here's the European, the GFS. They won't do that. So, this has implications for the grain markets in Central and Brazil where they need the rain. Phase 8 is very wet in Brazil, but it also has implications for the Midwest. You'll see with the drought monitor map, they need to get some rain here in the Midwest, and phase 8, is just not great for them. And it's also a continuation of the problem we've had all winter. Remember, back in December, the models were showing it was going to go into phase 8 and it looked like Christmas week. New Year's week was going to be stormy and cold on the East Coast with all sorts of blocking and big troughs and low pressure areas. That didn't happen. Then in late January into early February, the models, the MJO again came around. The initial projections were, is it going to go into phase 7, phase 8, and it didn't do that. And now it's doing it again. As we go from March into April, it will not do that. It will go into the neutral circle. And there must be a reason why this is happening, and it might be connected to the warmth of the oceans. Now, this is the, I showed this map over on the Facebook page and the Twitter page earlier. This is of course from Eric Smith. You can see the temperature anomalies for the winter. This is very typical with strong El Nino winters and super El Nino winters. This El Nino was the 8th strongest on record, in case you did not know. So it wasn't a record, but it was not nothing. It was 8th strongest on record. Snow map, look at this, just terrible. And now this only goes to February 21, but it's almost the entire winter. And you can see, and we know what happened last week of February, nothing. So you can see the huge snowfall anomalies here, the Ohio Valley, Northeast. Only a few pockets of good snow here, but generally, 60%, 80% normal. Some areas 40%. Now in Tennessee, they did have that big snowstorm in Tennessee. So they had a big snowfall there relative to normal. But then you can see northern Iowa, Minnesota, the Dakotas, Wisconsin, very into South Dakota, really Montana, way below normal snowfall. This has been going on for a while. This is the last 50 winters. You can see the snowfall anomalies have been increasing. Now you look on the East Coast for a second here, and you can see, let me call up a marker. There we go. I'll call up a marker here. You can see right along here, the East Coast, this is over the last 50 winters, all right, 1973, 74 to 2020, 23. You can see that they've been above normal East Coast, and that's because back around 2000, remember, we had a lot of great winters, 2002, 2003, 2003, 2004, 2009, 2010, 2010, 11, 2013, 14. We had a lot of great winters here along the East Coast, but the rest of the country, the Midwest, the Plain States, the snowfall has been really underperforming as the climate warms up. And you can see here in the area here, the precipitation amounts. Let me just clear this out here. You can see that, again, this is the entire winter, way above normal on the East Coast, from Georgia to Maine, okay? 200%, 300% above normal here. And then also in the plains into the Dakotas, but you've been dry in the Midwest here, also kind of the Ohio Valley. So, and then really, really dry in Wyoming, the Western Dakotas, and Montana. Here's the drought monitor map. And again, this is a pretty dry map here. We've had this dryness in the Midwest now since last summer. And because we did not get a lot of rain in the Midwest this winter and no snow cover, as you can see, the dry conditions in the Midwest really haven't disappeared. And we need to, in March and April, we need to get this rain really to come in here in the in the upper Midwest. We really need to get that rain in there to get rid of those D2 and D3 conditions, because it looks like we're headed for La Nina. And that's very dry. That's usually a very dry summer, and we know that. Just to show you, this is also the trend over the last 40 years. I mean, look at the actual last 50 years. Look at the rainfall here over the last snowfall. And this is the trend for temperatures. Look how warm it has been over the last 50 years. It's just, this is a warming climate. That's what this is. Now, you can say, well, that's part of the natural if you want to say that. You're wrong, but you can say that. But the point is, it is warming. We are in a warm cycle. That's what we're saying here. For whatever reason you want to ascribe it to, we are headed in a warm cycle. All right, here's the latest ENSO conditions. You can see that all the regions here, Australians on the left, the CPCs on the right, it is weakening. There's no doubt about that. And you can see that more here. Now, this is a comparison of the subsurface readings. This is February 27th. This is March 5. Right along here is the equator, okay? This is the equator. So this corner here, coast of Peru right here, and then this is out towards the Philippines. So you can see that we still have this pool of warm water here, February 27th, and you can see the cold water is bubbling up. But as this warm water dissipates, the cold water takes over. So now you can see the warm water has really collapsed. As of March 9, it's gone here, and now we have the cold water coming up. So the La Nina is coming on fast. You can see the changes here. These are sea surface temperatures as of March 9th. And again, this is from Alex Borum from Cyclonic Weather. And you can see the warm waters. Look how warm the Atlantic is. That's not a good sign for the hurricane season, though it's cooled off recently. More importantly, let me get a marker up so you can see this here. Notice the cold pool. Notice the drop in the temperatures right here. Now, it's still fairly warm here, sea surface temperatures, but it is definitely dropping as the El Nino is collapsing. And then in the Pacific, we have the warm water off the coast of Japan and the cold water in the Eastern Pacific, which is a negative PDO. This is the latest trends for the last 15 days. There's look at the cold, cooling water here in the Eastern Pacific. What that means is that's going to put going to favor a trough in the West Coast, Eastern Pacific, and more ridging into the Midwest and the Plain States. That initially makes for a stormy pattern, but if this holds into the summer, then it changes and becomes a hotter and drier pattern. And then look at the big drop in the ENSO here off the coast of Peru. You can really see the waters dropping off here. And then in the Eastern Pacific, the sea surface temperature anomalies here have dropped off a little bit over the past 2 weeks. But this, I think, is the big change here. This is telling us La Nina is coming on fast. Now, the oceans remain, relatively speaking, quite warm. You can see that if we look at the values here. So this red line is 2023, and this is 2024. It's even warmer than that. So 2023 was quite warm relative to the mean. And then you can see it's even warmer here. So the oceans are really very, very warm relative to normal. All right. This here is the latest CFS. And you can see latest projections here. You can see it's really dropping off. Look at the values. Now, the dashed black line, that's the mean of all the red and the blue and the brown lines. So this is showing now by June or July, we're in moderate La Nina, 1 degree centigrade by July. And then it goes to October. As they go into the heart of the hurricane season, it might become strong, a strong La Nina, which is not what you want to see for the hurricane season at all. This also increases the chances of a drought in the Midwest of the Plain States. Look at these different models here. Now, this is the European from March 1st, okay, and you can see there's weak La Nina, drew the line, there's moderate, and there's strong at the bottom here. So most of the European model runs here, a few of them are in weak, a few are moderate, a lot of them are neutral. But it's trending that way, there's no doubt about it. It's not as cold as the CFS, but it's trending that way. Of more importance here is the British model. The slope here is very sharp and steep like it is on the CFS. You see that? Very sharp slope here. And as a result, the British model, let me blow it up a little bit so you can see it. You can see, look how the numbers go way down, and you can see it has a lot more members, that strong La Nina, by June and July and August. All the members are weak. You can see it, all except for one of them are weak. And then a lot of them are moderate, and definitely a lot of them also are strong. So the British model is just like the CFS, and that has me worried here. The spring pattern, again, this last 50 years, it definitely has trended warmer, just like the winter. So it's not necessarily a winter problem. It's also just a warming pattern. Now, if we look at the trend If we look at the years where you've had an El Nino, a super El Nino, a strong El Nino in the winter, which is faded to neutral conditions during the spring, we get certain analogs that show up here. And you can see the analogs at the top of the image here. Call it up so you can see it. There you go. So 2016, that April, May, June, 1998, 1984, 1973, 1966, 1988, 1952, 1954, 1964, 1995, and 2003. All those years had El Ninos that faded, that was super strong and faded to neutral in the spring into the early summer. And the precipitation is pretty dry in the Midwest of the Plain States. Not great here. Not too bad on the East Coast, but really dry in the Ohio Valley, the Upper Mississippi Valley, and the Delta region. And you can break that down even more. Here you can see April, which is not too bad. May is very dry, and so is June. So that's what that looks like. Now, if we look at the temperature anomalies, again, looking at El Ninos that were either super or strong, where they drop to neutral. And you can see, generally, these temperatures are fairly cool. There's not a lot of heat. Taken as a whole, April, May, and June. If you break it down by month, April, again, not pretty close to normal, a little on the cool side on the East Coast and the Southwest states, but pretty close to normal here. But look at May. May is very cold in the Ohio Valley and Mid-Atlantic. This is kind of indicating late season frost possibilities here. And then June, look how June really warms up once we get into June. And this is just another snowfall image I wanted to. This came from Brent Schneiderman. You can see that the snowfall trend over the last 50 years has been quite noticeable in the month of March. Now, this is just for March, now not the whole season. So what I want to point out here is look at the anomalies here in March. And I've said this before many times. Over the last, since the year 2000, there's been a lot of March snowstorms in the Northeast. Now, we're not going to see one this year at all. But we have seen a lot of them over the last 20, 25 years. In the Northeast, from Richmond up into Boston. It's just kind of an anomaly which exists there. Everybody else west of the Appalachians, all the way to the Rockies, has had a very big drop or change in the snow cover in the month of March over the last 50 years. All right, this is temperature anomalies since March 1st. And you can see how warm it has been. Just unbelievable, right? Not a surprise given the pattern, so it matches the trend for a warm spring in the upper air pattern. So here we are now. Take a look at the period from March 15th to the 30th, looking at surface and upper air maps. So these were actual temperatures yesterday. Let me bring those forward. Where you can see the temperatures on Wednesday afternoon, a lot of 70s and 60s far to the north here, a pretty mild pattern, some 80s along the Gulf Coast in Texas. And this is the upper air map. So we have this big trough here, upper low in southwestern states, the big ridge in the eastern Pacific into British Columbia, a blocking pattern in Greenland, and a ridge in the eastern United States. So this ridge here in the eastern United States is connected to this trough here, and that's connected to this ridge. This is almost an omega ridge pattern, shaped like the letter omega. See that? So as we go further in time, this here's the current surface map. So the front is dividing the warm air and the cold air. So you look at the north of the front, you see temperatures in the 40s in Nebraska and Iowa, and 30s in the Dakotas, Minnesota. And south of the front, you see 60s and 70s, all the way down to some 80s in Texas as well. So this is, the front is pretty potent. Now, the upper level low in the southwestern states, let me bring it forward again. There it is, southwestern states. This piece of energy drops down. This is Friday night, Saturday, okay? So let me blow this up a little bit for you if you can. Bring forward. And then we can see that the upper low is here, and there's another piece of energy dropping down this way. You see, this is the trough here, the other side of the ridge. So again, this is a mega ridge, almost a Rex block, because now you have an upper low underneath the ridge. So that's a Rex block, really. And there's also a piece of energy coming down this little shortwave right here. So this is going to drop into the Midwest and then into the East Coast and drive a new cold front through and bring in the cold air. Now, the blocking, which was in Canada, Northeast Canada, is falling down. The NAO is going almost neutral or positive here. So there's an upper low in Greenland. So the block is breaking down. So what we have is a ridge on the West Coast, a split flow pattern here, and this trough piece of energy coming southward. That is for Saturday. And there's the cold front coming through the eastern United States. Nice big cold high. You can see right here, a lot of cold air behind it. The front comes through on, excuse me. comes through on I guess this would be a Friday into Saturday, and it's some rain for the Midwest, as you can see, the Ohio Valley, but the front and the Tennessee Valley, but it falls apart. It doesn't do much for the New England or the Mid-Atlantic. All the rain is like restricted to the southern states here. All right, longer term, let's look at our teleconnections. We have, of course, our Pacific teleconnections, or EPO, negative or positive, the Alaskan Ridge, Alaskan Trough. Here's the PNA, which is the West Coast Ridge or West Coast Trough. And then on the Atlantic side here, we have the AO, which is the Arctic Oscillation, positive, negative, and the Greenland Block when it's negative, or the Greenland Low when it's positive, the NAO. So these are all the different combinations, as you can see. And if we look at the Atlantic side first, well, notice here that we see the Arctic Oscillation up top, and this is the NAO. The Arctic Oscillation, there we are, the black dots, we're right here neutral. It stays slightly negative and kind of drops off a little bit negative towards the end of the month. All right. Once again, the GFS is the red solid dots, most negative, most extreme. And there's the NAO. And again, you can see the GFS is more extreme than any other model. All the other models keep the NAO around neutral right through until the end of the month, except for the operational GFS, which is bonkers. On the Pacific side, here we go. We have the EPO, the Eastern Pacific Oscillation, or the Alaskan Ridge Trough. There we are. We have been positive. We're neutral right now. Most of the models show going strongly negative, which is good for cold air production. So that's helping to feed the cold air coming southward from Canada. And the PNA, which is the Pacific North American pattern, it's neutral, and then it goes positive for the most part, and then it goes back and forth, and you're neutral here. The kind of split as to what happens at the end of March here, but we get some positive values here. So that's a pretty good source for cold air on the West Coast. The problem is there's no blocking in Canada to produce an East Coast late season winter storm. So what happens is here, the trough comes pushing southward. It gets a very big trough here Sunday, Monday on the over the eastern United States. Now look at the ridge. It becomes an omega ridge here. There's a kind of a Rex block underneath it. Actually, this omega is actually more like a Rex block here with this upper low in Baja and Arizona. Now, this trough has two pieces of energy with it. The first one here, the cold front that comes through, all right, it's off the coast here. Look at these howling north winds bringing a lot of cold air Sunday, Monday, and Tuesday for mid-March. And then there's a clipper low coming in behind it. Now, there was some speculation earlier last week that these two areas would meet and you get a big East Coast storm, but that's not going to happen at all. All right, by March 20th, you can see what's going on here. The European is on the left and the GFS is on the right. There's some discrepancy as to where the trough's going to be. The European has the trough running here northwest to southeast from Hudson's Bay to Virginia. The GFS is faster with the trough. It's already lifting back up into New England. And then both models showed, remember the ridge that was in the west coast of Canada and Alaska? Let me go back to that. You remember this ridge here? Look what happens to it. It begins to retrograde. It goes back towards the Bering Sea. See that? See how it's moving back towards Alaska here, the Bering Sea? That allows the energy in the Pacific to begin to ramp up again. And you can see a lot of those short waves and low pressure areas coming in on the strong Pacific jet stream on the European and on the GFS. So this is the European by 168 hours out, which is March 21. The trough finally begins to swing through Virginia, through the mid-Atlantic, heading up towards Newfoundland, Canada, right? And the block is now left Western Canada, is now in Alaska, and that allows the Pacific energy to come blasting through with more mild temperatures, pushing the cold air out of the way eventually, and bringing in more potential storminess. We can see a lot of energy here in this southern jet stream. Look, a big low here, another one in the Pacific Northwest, another one in Texas and New Mexico. These are going to become big storms later on. Now, eventually this trough, like I said, swings up towards Newfoundland, Canada. You still have some cold air coming in with this clipper low on March 20th. And again, there was some talk about this at the beginning of March, or the first week of March, that these two pieces of energy would meet and you get some sort of big storm here, but it doesn't happen. Again, there's no blocking at all in Greenland or Eastern Canada, nothing to slow this system down. So it's a cold front, it's a big trough, it swings through, and then it's gone. That's what happens. It's March. Okay. Now, this is March 22nd, and we can see that the pattern is really changing. Look at the energy surging in here. right? All this energy coming in. This is March 2021. Here's March 22. I mean, it's just rolling through here, the energy. Now, this is the GFS in the upper left. Here's the European in the bottom right. Look where the ridge is. That was in Alaska. You can see it's way here, right? Well, it started here. Look how far back to the west it's moved. And that's allowing more energy to come in. Now, the European has a big trough in the Pacific Northwest, another impulse in the Delta, which is going to produce rain for the eastern United States and the deep south. So does the GFS. We'll see that in a second. Here's the European solution. It's got the rain, one system in the Pacific Northwest. Oops, here we go. Here, the Pacific Northwest. Look at the cold Arctic high. There's a lot of cold air up here. All right, and then you have the southern system developing rain in the Gulf Coast, the southeastern states, into the Ohio Valley, which reaches the East Coast eventually. This rain reaches the East Coast. Now, the GFS has this coastal storm on March 22nd, 23rd. The cold high to the north. Now, if this cold high, this is fairly close to being a snowstorm on the GFS, but I think the solution is wrong. I don't think the cold air is going to get that far south in time. I just don't see it on the model. And again, if we had the blocking here, we'd be looking at something much more serious on the East Coast. But so we just don't have it. And then you can see what happens. The European takes this system, okay, in the southeastern states, and it does this, moves it up the East Coast. And you get snow in upstate New York and northern New England, heavy rain in the mid-Atlantic into Pennsylvania, southern New England, New York. And then the Pacific system drops southward into Kansas and Colorado and Oklahoma and Texas. And to the north, again, a lot of cold air here. This is impressive cold. I don't want to downplay that. It's very impressive cold, but most of it is along the U.S.-Canada border. There's not enough forcing in eastern Canada to push the cold air in Quebec southward. So it mostly stays along and north of Interstate 80, right along in here. Now we go further out in time. This is March 24. We're in pretty good agreement here. The European is on the left, the GFS is on the right. Both models have a nice trough here, all right? In the Pacific, I guess this would be the Rockies, Southwest Canada. They both have a pretty big polar vortex. And you also have the southern energy here in the southeastern states. Both models have that. Now, the one difference is that the GFS has this trough shaped a little differently. It's got one piece off of Baja California, the other one in the Pacific Northwest. The European is more uniform. And again, look where the ridge is in Alaska. Not on the West Coast, but in Alaska. And that favors a trough in the Rockies or the Plain States, which means the ridge in the eastern United States. So this is an active pattern, a lot of energy here. It's not particularly warm, but it's not particularly cold either, and it looks fairly stormy from what I can see. And then here we go, the last couple of days of March. Now all that energy coming in from the Pacific finally moves eastward, and we get a big negative trough anomaly in the Plain States in the Midwest. This looks like a major rainstorm. For the plains of the Midwest, they could use it, warm on the East Coast. Notice the polar vortex here is weakening. It's gone almost. The ridge that was in the West Coast and then Alaska, that now shifts up to the Bering Sea. So this is just Pacific flow, folks. That's all this is. It's just energy coming in from the Pacific straight this way. Nothing to stop it. So this looks like a nice rainy event for the plains of the Midwest and eventually the East Coast at the end of the month. This is March 27th. All right, that's me. That's the report there. Hopefully you enjoyed it. This is meteorologist DT from Weather Risk. I will see you over on the Weather Risk Snowstorm page and then over on the website and on the Facebook page.